So describe the importance of ethics in research. Detail a few examples of experiments you read about yesterday pertaining to ethics in research. Anybody know when picture retakes are? I need to know. I missed the first day. I missed picture day.
Oh, retakes, like the very first picture day? Retakes already happened.
Guess I won't be in the yearbook. Oops. Missing photo. That's what I'll say. I'll get a picture of a Trojan there. Nice.
Did you miss both days?
I must have. I didn't know when the second day was.
If you can just go ahead and pick up all of them.
That'd be cool. I always wear the same shirt and tie too. I was gonna do it my whole career. See my change over time. So I might have messed it up right here. Oh yeah, I can. I'll ask her about it. All right, so let's go over ethics and research. Why is it important? Why is it significant? Natalie, what do you have?
I said ethics are important because that way it will come out of score.
Yeah, good job. So whenever we're performing research, performing an experiment, we need to make sure our participants are protected. So if any type of data or representation of the data is not, let's say, ethical, let's say it's unsuited, or maybe cause harm for this person in their future, we need to make sure that we can cross those rules, those expectations for ethics. Good. So with some of these experiments, those detailed some of the issues that arose, maybe some of the unethical situations that were brought up, and how we can make sure, if we ever are performing an experiment, we make sure we ask for permission to use their names. If not, then we have to make sure it's anonymous. Okay. And again, protecting the participants of these experiments so that there's no harm done for the rest of their life. So, what experiment did you think was very, I say, interesting but unethical? Haley, which one did you write about? The Stanford prison experiment? Yeah, good job. So Zimbardo, Stanford University. He was what? What was he doing? Yeah, yeah, good job. So he's simulating really a prison, only with college students and within a part of Stanford University in like a dormitory. And he tried to simulate the power struggle between prison guards and prisoners. And with that being said, his results were alarming. Okay, he saw that these people, these participants that were acting as prison guards, really abusing their power in this simulation. And we talked about it, independent variable, there was none. But at the same time, when you look at the scientific method, we look at it, it's like, oh, well, we can't really respect this as a study. But there were a lot of results that were very proven, right? It was actually proven to the point where this simulation was really justified explaining his meaning of a power struggle in a prison and how this simulation was very accurate, right, to his predictions. Even though, like I said, it doesn't follow that scientific method well, this simulation did a good job at reporting and concluding his results. All right, so this was designed to last how long? Did the article express that? How long the study was supposed to last for? Allie? 2 weeks. Yeah, good job. And they pay the participants, right? Yeah, it was like $15 a day or something like that, right? I think it was 15. Not sure. But anyway, for college students in the 1970s, that's a lot of money, right? It's a lot of money. And they thought it was going to be a cakewalk, a breeze, but it wasn't, right? It wasn't. And how long did it actually last? No? Anyone know? Allie? Yeah, 6 days. Okay. So with that being said, it didn't even last the full amount. And it came to a point where Zimbardo, he was acting like the superintendent of the prison. He was even catching himself falling into the simulation. He was actually thinking he was in charge of this prison. And he was calling his inmates, right? He wasn't even viewing them as participants of his experiment. And it really goes to show how drawn into the experiment he actually was, believing it was real. And took his wife to pretty much smack him in the face about it. It's like, yo, calm down. Like, these are kids. They're not actual prisoners. All right. What other one did we write about? Hallie, I'm sure you wrote about Zimbardo then, right? Allison?
I said the little algae experiment.
Yeah, what was that all about?
They were testing a baby, and whenever he would see a white rat, he would make like a loud sound, and he'd start crying.
Yeah, in the background, they'd be crashing things together, making loud noises whenever the baby would see the rat or the mouse. Yeah.
And after they studied, they didn't extinguish his fear, so that's why he was in.
Yeah, it was like creating a paranoia for this small child.
And he would also cry when he saw other white things. Like food.
Yeah, yeah. So maybe like a coat, like it was, let's say, for he'd start crying because it's associated with that fear, that paranoia, and a loud banging noise whenever he saw a furry rat or a mouse. Yeah, that was an interesting one. Just literally creating fears in small children. Oh my gosh, terrible. Christian, which one did you write about? Okay. Kiara? Okay. Andrew? Katie? Oh, Noah? Which one did you write about? Oh my gosh. Well, anyway, Kiara, you're talking about the Milgram study, right? Yeah, what was that all about? What?
Give me a.
All right, so Stanley Milgram, he was trying to almost run a small simulation of how people fall into tendencies and fall into authoritative measures, right? And he was trying to reflect it off of Nazi Germany, how many people, citizens in Germany, just followed suit of what the Nazis' orders were, and how they're committing these harsh atrocities to many Jewish minority people, right, in Germany at that time. And he tried to reflect this through teachings, right? So this teacher would say, hey, here's a shocker for the electric chair. There's a participant in an electric chair. Whenever he answers a question wrong, you need to deliver a volt, a shock to this person. And the person given the electrical shocker, right? He had no clue that the person in the chair was an actor. He wasn't really shocking them, but he thought he was, right? Okay, so it was just kind of acting in a way, right? It was just like a fake simulation. Like there was no actual pain given to that person sitting in an electric chair, but the person with the shocker thought there was. And the whole time it was like, hey, he answered it wrong. You got to shock him. He's like, okay. So the first time he gives him a shock, and the actor screaming in the chair is, oh, I can't do it. No more, no more. And then the experimenter, the person, the teacher, is saying, hey, ask another question. If he gets it wrong, we're going to amp up the electrical volts. Okay. And every single time that person got a wrong answer, he had to click the electrical shocker. Then to a point, the person holding the shocker was like, I probably should stop this. This is not right. This is not something that we should continue to do. And the teacher's like, well, you have to deliver the shock. This is part of the experiment. You signed up for this. You signed a contract. And the person's like, this is unbelievable. I can't leave. I can't continue to do this. But what do you think he did? Continued to shock the person in an electric chair. Again, no one was hurt. It was all acting. But it just goes to show how individuals could be persuaded. Right, like that, right? Like Nazi Germany. Pretty crazy, right? Pretty crazy. All right. So is there any questions on those studies? See how unethical they are? Oh man, crazy, crazy, harmful situations. All right, terms for today. So again, hopefully that spurred some idea of maybe what experiment you would like to research. I don't know if you filled out in discussion posts. I'll check those as soon as I'm done here. And you guys can start working on your experiment project presentations. Remember, Friday is when we'll have those presentations. A reminder, it's not read straight from the slide. Make sure we cite in APA format. If you need to check the citations again, it's on the syllabus, right? On Canvas, you'll see how to properly cite in APA. I'll show you that if you want, if you like me to, towards the end of class. These terms you should already know. Allison Wright, 5th grade math. Okay, so again, I'm not going to focus on it too long. We're just going to move through it. It's just part of the curriculum. I have to talk about it. And then standard deviation. Standard deviation.
We actually learned a song about.
Oh, yeah, we go.
What? Let's hear it. Come on, Allison. You brought it up. You got to say it now.
I was actually gonna say.
Kiara, you want to sing it? Christian, you know it? Yeah, you do. You don't remember it, Haley? I don't know it either. I'd like to hear it.
I can give you the words to it.
Go ahead.
Let's start the fun range. Divide the hand between those and over the supermost. And we need the middle.
Oh, okay. You sound like the end of those commercials when they're trying to read fast. All right, so let's move on here. Frequency distribution, you guys know this. So a summary chart which shows how frequently each of the various scores set of data occur. And you can really test this with anything. All right, time on social media. I was going to have you do your own little frequency, finding the mean median mode with different things, but I figured you guys know this already. It's going to be a review. We're going to move on. Again, it's in the curriculum, so I got to talk about it a little bit. So frequency distribution is just showing the represented data. So how we're going to gather this data, represent and show it within our study. If we're trying to, let's say, perform an experiment, find results, let's say through surveying, okay, we can report our findings through many different ways, through charts, through histograms, through frequency distribution charts, you name it. And with Google Forms, I showed you that already. The pie chart does it already for you. I'm sure there's a way you can chart it differently too on Google Forms. I just don't really look into that too much, but with the pie charts, it's pretty easy to see and how data is represented. Like I said, when I was in college, when I was collecting data, I had to draw it out myself. Google Forms now is just so much nicer, so much easier. All right, so using data for analysis, histogram, you already know what a histogram is. So we have two different variables. We see the relationship between the variables as reflected with the chart. Okay, so here it is, salary by the thousands, number of employees, right? And you can see how that data is represented. Great way to show your statistics, show your results. And when you're concluding your experiment, it's important to note, important to show the results of your experiment, the results of your study. So reporting your findings, concluding your study. All right, so mean, median, mode. You guys know this. Mean is the average. I don't really have to talk about that too much. So you're adding up the data, dividing by the number of pieces of data, and you're finding that average. Mean, done. Median is a measure of the central tendency, so the middle of the data. So when you group it together, you sort it, okay, numerically. The medium set point is a median. If there is no middle, you have to find the average of the two that are focused in the middle. We know that. Mode is a measure of the central tendency, which represents the score that occurs the most. So if we have data that's repeating, okay, more times than others, that is the mode. What appears the most? All right, so here we go. Quick scenario. I'll let you guys find the mean, median, mode of this set of data. You should be able to see it pretty easy. The weekly salaries of 6 employees at McDonald's. 140, 220, 90, 180, 140, 200. There you go. Find the data here. Find the data. Almost forgot Connor, current events. So if he's watching this video at home, hopefully he's liking, hopefully he's subscribing. And he has his current event for Friday. Good stuff. We need more time? Yeah, I guess so. Okay, I'll give you a little bit more time. All right, so what do we got? What's the mean? What do you have for the mean, Allison?
161.
There you go. Good job. 161.6 repeating. Good job. And then the median. Oh, sorry. What's the median? What do we have for the median, Kiara?
I don't know, I kind of did that one in my head.
Natalie? Yeah, there you go. Well, I'm glad we're doing it. All right. Glad we're doing it. What about the mode? Christian? 140. All right, good job. Good job. All right, standard deviation. So standard deviation in simple terms is just how the data is dispersed from the mean, from the average. Okay. So obviously when you find the average, you're going to see how that data is dispersed, whether it's a positive, a negative, or a normal standard deviation. So it's how far or how close or how dispersed this data is represented, showing towards the mean, towards the average. So low standard deviation indicates that data points tend to be very close to the mean. So all the data is pretty close together. So let's say we take a test in here and we're all hovering around, let's say a 95. Yeah, we're doing well, right? So a 95, we might have data points that are like, let's say a 93, a 96, 95, all close to the standard deviation, close towards, towards the mean, right? So that means we'll have a low standard deviation. If we have a high standard deviation, that means we might have, say the mean, the average is around a 90. We might have data in the 60s, in the 70s, maybe a 50 or 40. Hope not, right? Right, Christian? Hope not. That just goes to show that the data is dispersed over larger, separated a lot more from the mean, from the average. All right, so here's an example of a normal distribution. So the standard deviation showing and expressing from the mean, right? Showing that the data is fairly close to where the average is. So normal distribution expressing that the data points are fairly close, fairly low standard deviation. Yeah, you have outliers here and there, but for the most part, a lot of the data points are generally focused towards the mean. All right, they represent that distribution as a bell curve. I'm sure you've seen a bell curve before. They call it a bell curve just because it looks like a bell, right? And as you can see with a normal distribution, a lot of the data points, 68%, are very close to the average, close to the mean, right? 95% very close as well. And you might have a few outliers drifting towards a negative or positive location, further away from the mean. But with a normal distribution, it's represented by a bell curve, a bell-shaped curve. And it looks like a bell, obviously. So again, a lot of the data is focused around the mean. As you can see, 68% falls right close, okay, not even, let's say, 30 data points away. 95% very close, like I said, to the average, to the mean. And then you might have a few outliers that, let's say, are higher, okay, a positive or a negative, okay. And here's how that's represented. So positive skew means that it's a long tail in the positive direction. So a lot of the data points are skewed in a positive direction. Negative skew, long tail in a negative direction, right? As you can see, in a negative direction. And we all know the normal distribution, which is shaped like the bell curve. All right, so we'll talk about correlations more tomorrow, and we'll finish really the chapter notes tomorrow. And Friday, we have presentations of the experiment, project presentations. Hopefully, we can get them all done Friday. So please use your time wisely, work on that. All right. and have that finished up for Friday. Remember, don't read straight from the slides. Make sure you talk about the different variables included on the activity of what I assigned, what I expressed, and talk about maybe how it crossed ethical boundaries. Okay. You guys got it? Awesome. So your assignment for today is attached to Canvas. Oop. I'll bring that up. Modules. All right, so data representation, there you go. Again, shouldn't take you too long to complete. Pretty self-explanatory. All right, there you go. That's all I got for today. Minor work on your presentations if you finish this up.